I be down there with a Redfern grow, sitting on a bank line in the water. When the crickets start to sing and the stars come out loud, she gets hotter. I ain't gotta prove a thing to her, so this is my home, it's all that I know. I'll be right here.
Starting to work with some civil engineers to do biochar and turn
For
it into
building material.
Oh yeah, like
Biochar.
hempcretes, all sorts of things.
Okay.
They use all sorts of biochars in that, and so any kind of hemp waste, you can biochar it and put it in. So we just
As an additive?
As an additive.
Okay.
Yeah.
Okay. That's awesome.
And so, yeah, there's a guy out in Charlottesville actually who's just taken all agricultural waste, including some of this hemp stuff, just biochar it. He sells it for $400.
What? So he's taking waste, farmer's waste, and turn it into straight green cash.
And then just travel. We take the fiber, either the raw fiber or the fiber, and then you can take that and you can cryo-mill it down to a small size. Little particles. Like you would take this, and we can get this down to 100 microns. We take that, you can then chemically treat it to break down the lignin down to smaller carbohydrate components, smaller sugar components, which then you can feed in to a fermentation system, and it will ferment it to make smaller starting materials that can then be used for making all sorts of byproducts. But the one that we're most interested in is sustainable airplane fuels. But you can use it to make things like astaxanthins or other additives that are complex carbohydrates. So you break down the fiber, then you rebuild it into whatever you want.
So you're going to break this down, and you got your one industry that you're going in, but it's universal. It is very unique.
Yeah, there's a number of different processes you could use that to take the lignin once it's broken down and then make it into anything you want. It basically is just the starting material for fermentation. And the idea is that right now you have to chemically treat it very harshly. But we've come up with ways that are less harsh and more environmentally friendly to do the conversion.
Got it.
Right?
Got it.
So that's the idea.
But that's the way you are going to need to put it through some chemical process to break. Is that breaking it down?
Right.
Okay.
So we're working with the USDA up in Pennsylvania. There's a gentleman up there that has worked out the fermentation process and the treatment process, and then we're giving them the material as starting points. And so what we want to know is each of these different lines has different fiber contents, and the fiber has different compositions. Which compositions work the best?
Got it. And is it possible to take, I don't know, your best three, put them in just, so you can go bulk on three of them, mix them together?
You could do that.
Okay.
Right? I mean, what we'd like to be able to do is look to see which cultivars are actually the best composition, right? Balance of liquids, and then those would be the ones you would want.
Yep. So you're always starting with a plant, and whatever genetic makeup that plant has got.
Because not all the hemps are the same.
And they yeah.
So these are combinations of fast and
Yes, this is the whole plant.
whole plant,
Yeah. This is the whole
which is
plant.
great.
Yeah, this is literally that stalk, job done. And yeah, I mean, we're excited. I just want to see what all you can get from it.
Well, as I said, we've given material like this to one of our engineers who's going to be seeing if he can turn it into starting materials for 3D printing building materials.
That's awesome.
Yeah.
That would be amazing.
Yeah.
Blocks, like a Lego house.
Yep. Exactly.
That's the way to do it. That is the future. when it comes to especially sustainable material like this.
So we've worked a little bit with a couple of companies that were interested in making laminates, and fiber cryo milled it down. And we gave it to them to see if it would work in laminate. So the plastic coating you got on flooring, your credit cards and so on, and they showed that it worked really well.
So
But
when
they
you're
thought
breaking
that-
it down, when you break it down to that nanoparticle, what is it? Dust.
It's dust.
Yeah.
It's basically a dust. Yeah.
And then even just in the raw form, I can see that being a strengthener, like just an additive you could add to
so the thing you have
as
to
a
do is
binder.
like if you have this stuff here, it's really uneven. I mean, so you get it down to a uniform matrix, right? So that you could then blend it properly, so you don't get like lumpiness.
Measuring and here's how much you put in it,
Yeah.
and you can get it back in dust, and then you would add it to whatever application. That is fantastic.
You have to have it's got to flow and mix.
Yeah.
Yeah, how you make concrete, right?
Yeah,
It's got to
exactly,
flow.
100%. But with the same property, still has the same property, the strengthening, binding
It's good for the
properties.
strengthening, but you're using less lime and stuff, so it's more added.
Yep. Hemp.